In this video, I will explain you what is Gauss theorem. We will see the definition first. Electric flux linked to a closed surface kept in an electric field is 1 by epsilon 0 times charged enclosed in the surface. What does it mean? We have a charge plus Q and it is enclosed in a surface of area S. Then the total flux linked with this surface is equal to flux, total flux. So this is integral, right? For the closed loop, the total flux is equal to 1 by epsilon 0 times charge enclosed. So flux, electric flux is equal to 1 by epsilon 0 Q or Q by epsilon 0. This is the mathematical representation. Now to get the value, we have to do a closed integration of phi e and we will get the value as Q by epsilon 0 on the right hand side. This is LHS. Now we will check whether this is right or not with the values we have learned. So we know the case of a point charge, right? Around a point charge of plus Q, I am going to consider a loop, and this is circular, which means all the points in the loop are at the same distance away from the center, and at the center I am keeping a plus Q. Now this also gives me an information that electric field at all the point will be same. What will be the electric field here? 1 by 4 pi epsilon 0 Q by R square. Here also 1 by 4 pi epsilon 0 Q by R square, because the same source charge and the distance is also the same at all the place. Now we have learned an equation here. How to get the total flux? Integral, closed integral phi e. The total flux with the loop with the closed surface is equal to 1 by epsilon 0 times charge enclosed. This is what Gauss's theorem says. Now how does the flux is getting linked with this surface? We know that from a positive charge, field lines will be radially outward. Now all the field lines which are coming from positive charges will be passing through this closed surface. All the field lines, not even one field lines can escape without passing through the area we have considered. Okay, now we will substitute the equation here. So integral phi e, we know what is the value of integral phi e. In value we will get from E dot ds. We have learned in flux, right? Electric flux. And see one thing, see E dot ds is nothing but E into ds into cos theta. Now what is cos theta here? At every place, if you are considering an area, its vector, its area direction will be perpendicular to the area, and in the previous case I have explained you, always you have to consider those area which is outward from the closed surface. So closed surface has two positions, one is points inside and points outside. Now always this area have to be directed outward. You can also take an area in this way. Don't consider area or don't consider the direction of area in this direction. Always it have to be outward. But anyway, here areas at every point will be in this direction. Area, take the tangent. This is the perpendicular to the tangent is the direction of area. Take a tangent, perpendicular to that tangent is the area. See, everywhere area and electric field lines are parallel. So this will be cos 0. Parallel means E and area makes an angle of 0 in between. So that will be cos 0. Cos 0 is 1. So that will be simply E into ds. And what is the value of E? E is nothing but 1 by 4 pi epsilon 0 Q by R square dot ds. Okay, I'll keep the next step here. See, this value is same everywhere, right? It's same Q, and distance to the point in the closed surface from the source charge Q is same everywhere, 3-dimensionally across it. So I can take 1 by 4 pi epsilon 0 and Q and R outside because all these are constant. So that is total flux of the closed surface is equal to 1 by 4 pi epsilon 0 will come out, q by r square will also come out, and integral of ds. Now what is the total? Integral ds means the total area. Now see, this is a 3-dimensional surface, right? Around point, it's a 3-dimensional surface, it's a sphere. That point is now enclosed by a sphere. What is the total area of the sphere having a radius of r? It is 4 pi r square. So this will be 1 by 4 pi epsilon 0 q by r square, and integral ds is 4 pi r square. See, 4 pi will cancel, r and 4 pi r square, right? R square and r square will cancel. What is remaining here? Q by epsilon 0. And what is this? This one is the same thing that Gauss have told. So we have proved that electric flux linked to a closed surface, that is the electric flux linked with this closed surface, which is kept in an electric field. It's a kept in an electric field, that is 1 by epsilon 0 times charge enclosed. See, this can be written as 1 by epsilon 0 into q, where this is a constant and q is the charge enclosed by the Gaussian surface. I can name it as Gaussian surface. This is very, very important, and the application will come. So learn the proof and also the definition. It may ask for 3 markers. Okay, thank you.